open source packages. Nicolas is a professor in chemical engineering and production engineering courses, and also the coordinator for the Center of Applied Research at POC Campinas in Brazil. And together with Daniel Wagner, the inventor of the process simulator DWSim, he has launched the DWSim Social Responsibility Program, which aims at financing social inclusion projects. And today in his presentation, he will talk about the active methodologies based on open source software and problem-based projects. And he will present how the teaching learning process is facilitated by the use of computer simulation tools, and also how open source tools can help the teaching of thermodynamics, transport phenomena, and unit operations. So, warm welcome, Nicolas. I will hand over to you now so you can maybe give a short introduction about yourself, and we're very happy to hear your presentation.
Excellent. Thank you very much, Luisa, for the presentation. It's a pleasure to be with you guys. First of all, I would like to thank you to this invitation to make this presentation, especially Anna and the entire team of Simulate 365. So please, sorry for my bad English. I believe it's been more than 6 years that I do not practice my English. Especially because of this pandemic problems worldwide. So it's really a great pleasure to be able to share with you a little bit of my trajectory and how I have been using open source tools in the teaching of chemical engineering. So I use OBS to transmit my presentation, so I think it's better to pin my webcam, so I will not use the sharing tool of Microsoft Teams to share my presentation. So I will use something like this. So this is my presentation with my webcam together. It's also an open source tool. So let's talk about this idea. So here is my contacts. You also have my link tree here. I will send you the link in the chat. Okay, so you could have my WhatsApp, my Instagram, LinkedIn, and others links to get contact with me. Okay, so let's start talking about. Let's talk about open source tools. So first of all, I would like to make a really simple presentation about me. I have a degree in food engineering, and I did my master, PhD, and postdoctoral research in chemical engineering. And during my postgraduate studies, I was related in computational fluid dynamics, CFD, mainly in storage tanks and mixing vessels, with multi-objective optimization, CFD, and also in my postdoctoral research, I work with catalytic cracking with CFD also. So regarding my professional experience, I began to work like in 2002 in a company called ESSS, Engineering Scientific and Scientific Engineering Simulation Scientific Software. Currently is the largest company in Latin America. And in beginning of 2004, I was the responsible for opening the ESSS office in São Paulo, in Brazil. Initially focused in simulation for the chemical and petrochemical industry. And from 2005 to 2015, I've been responsible to the international expansion of ESSS, responsible for opening and managing the office in Chile, Argentina, Peru, and also some distributors in Venezuela. And after that, in 2015, I left the company, left ESSS, and started to work as a professor and researcher at PUC Campinas, one of the biggest private university in Brazil. So Also in ESSS, so during my time as a commercial director at ESSS, I was responsible for co-funding a company called Rocky Inc.
Yeah.
And this company is specialized in... I think that is microphone open. Oh, yes, fine. So this company is specialized in discrete element method simulations, DEM. And in 2016, I left my role as a co-founder at Rocky Inc. And at that time, we have like more than 3,000 customers worldwide and something like 40 distributors in the whole world. Also, I was a co-founder of a small company here in Brazil called Gato Preto Classics, a company that worked with tube amplifiers for guitars, so it's only a small company. So let's talk a little bit about how did I find out about like the WSIM. So at PUC Campinas, as a professor, I'm the responsible for the course of analysis, modeling, simulation, and optimization of chemical process. And in this discipline, we carry out about like a lot of practical classes using commercial softwares like Excel, Aspen, HiSys, and others. And in the beginning of the COVID-19 pandemic, started a really big question to me, how to teach this discipline remote. So without being able to access this license of these commercial softwares. And at that time, it was the first time that I met Daniel Medeiros and the WSIM. And at that time, it was like was love at first sight. So I start to work with DWSIM and expand the open source software work here in both in teaching class the chemical engineering and also in my research. So I start also at 2 years ago a YouTube channel here at YouTube. And in this YouTube channel, I make several courses, master classes, and tutorials, and also even interviews available for free, mainly in the area of chemical engineering and focus especially in open source tools. No? And during the last 2 years, also to help the dissemination of these open source tools, I was called to teach more than 20 DWSIM courses worldwide for free. And this is one of the ways that I start to contribute to the open source community here from Brazil. So that's enough about me, and so start to focus more here in the open source tools. And okay, yes, thank you, Anna. So fix the frame. It's very good to help to view my presentation. Thank you very much. So let's talk a little bit about this presentation, and let's try to explain how and why we could boost the chemical engineering learning curve through the use of open source packages. So here at PUC, we use a lot of active learning methods, and these active learning methods is really helpful to engage the students and help them to think, discuss, and create new things. So during these classes, we try to have the students to practice skills, solve problems, struggle with complex questions, make decisions, propose solutions, explain ideas, and help to have these students to have opportunities to produce very good material and apply this knowledge during the classes. So, Frederick, you could pin my presentation. Will be better to you to see my presentation, I think. Pin my webcam.
If you right-click on Nicolas' frame, there is spotlighting option. So you can use this one, and you can see Nicolas' presentation in full frame.
Thank you. Thank you very much, Anna. So at PUC Campinas, we work with a lot of active learning, like pair share, wide pair share, concept making, pooling, making predictions, problem solving, case studies, project-based learning, and also peer-to-peer review. This is very good to help these students to have very good ideas and increase the ability to solve problems. And if you think about like the industry 4.0, one of the main reasons that we use active teaching techniques is to enable our students to increase and increasingly prepared to work in the industry 4.0. And then if you take a look on these 9 pillars, we have system integration, we have big data, and also simulation of the 3 of these 9 pillars are really important to us. So many of us professionally imagine that we could only use compute simulation on the ending of the chemical engineering course. So using all the knowledge that we have in the separation process, momentum, heat and mass transfer, chemical kinetics, reaction design, process control, etc., only in the end of the chemical engineering course. But if you think about that, we only use like standard teaching when we have like the theory, make one exercise, like here in the control process simulation class, we make like mass balance, energy balances, make a Laplace transform, create like know the transfer function, simulate this process and have only one results. So if we start to work with simulation tools during the classes, what do you think that if we could have multiple scenarios and analyze things like cause-effect analysis, have better understanding of the physicals involved in each discipline, better understanding of the relationship between the process variables, analyze the effect of process and process variable in the OPEX or CAPEX, and also better understanding of technical feasibility. So if we think about that, we start to think not using simulation tools only in the end of the course, of the chemical engineering course, but also from the beginning, and use the computer simulation tool as a support for the separation process classes, unit operation, numerical analysis, thermodynamics, and also the basic things like solve differential equations and something else. So if you think about that, we could start to use open simulation tools to help us in the chemical engineering learning and teaching. So this is one of the open source tools that I use in my chemical engineering course, like the WCIN, OpenFOAM, also Arduino, OBS, Scilab, Python, R, and Octave. So let's start to share with you some of the cases that we work here. So the first of one, I would like to present you some example. This first example is the use of Octave in the chemical process control course. And we start here with the data acquisition using Arduino or ESP32, an open hardware, and then make the model identification, the first order, second order, or first order with that time, and also curve fitting with Octave, and then start to make some cause-effect analysis, simulate a lot of process, taking a look what happen if you change the process gain, the process time constant, the process dead time, and not have only one result, but a lot of results, and could help have this to better understanding the PID controllers, and also makes the tuning methods like Ziegler-Nichols method using like this, so making have a real data and fit this data with Octave, and have this data to know the process gain, the dead time, the time constant, and make a Ziegler-Nichols PID tuning using Octave. So also, as we know, one of the 9 pillars of the Industry 4.0 is the data analysis area. So we could use also other open source tools like Jupyter Notebook, Google Colab, and also Python to work with like something like data cleaning for machine learning analysis, work with multivariate sensibility analysis, getting and studying data for insights that can be using to make better decisions, and also ensure safety and efficiency of an engineering project. So with that, we work a lot with the WCIN. This is a case that we use with the students, and we use, in this example of multivariate analysis performed with conjunctions with simulation using DWCIN and Python script. So we run a lot of cases inside DWCIN. After we run the simulations in the WCIN, we collect the data in Excel or in a CSV spreadsheet, and analyze this lot of simulations, lot of a huge amount of data using Jupyter Notebook or Google Colab. And this is very good to know the relationship between the variables, the input and output variables, and other things. So let's start to focus a little bit more in the WCIN, that it's very good to us. And if you think about like one of the basics of the thermodynamics, yes, William sent to us that we could use, yes, Scilab is very good tool to work with PID control system. instead of Octave. Yes, it's very good. We work a little bit with Scilab also. It's excellent. So in the thermodynamics, we have some very good questions. One of my questions is why, like for the students, sometimes respond some questions like as simple as calculating a specific volumetric can be so complex. So in the beginning of the thermodynamic course, also the students have a lot of difficulty to understanding why and what really is an ideal gas. So what is the really difference in the results if we use different thermodynamics package models, and tools like DWC help us to know some results and show to the students some results beforehand, and this motivate the students to know more about thermodynamics and respond simple questions like if we like calculate the density of a gas using different thermodynamics model package could generate errors which can reduce a lot the probability of a chemical industry. So this is very useful to help our students to know that they need to know a lot the difference about this thermodynamic package and models that we use. So another thing that we work here, this is one of my contributions to the DWC. I work with a psychrometry package add-on or template, and this can be downloaded from my GitHub, or also in the DWC menu you could also download this tutorial. And in this case we could easily simulate process as humidification, dehumidification, drying, and on other process involving air treatment. And easily we could, with a simple and intuitive window, we could set the psychrometry properties of the input streams and also know the properties of other streams, like know the dry hub temperature, wet bulb temperature, calculate the degree of saturation, and other psychrometry data, and use that a lot in projects of like refrigeration and then air cooling simulation. We use a lot DWC in the discipline of thermal machines, and to help us to teach refrigeration, air conditioning, and also help us to know the difference about use a single stage system or a multi-stage refrigeration system involving ammonia or other mixtures of gases. So here I will present to you in the next slides some cases that we work with our students using project-based learning. So in the food processing area, we can mention the simulator of multiple effect evaporation system like this. This is a case of a glucose syrup 3-effect evaporation process. So this is very good to us to show to the students how to reduce the energy consumption in the industry. Also work with like milk pasteurization and sterilization systems. Orange juice concentration with also simulate the heat recovery inside this very important process here, like in the São Paulo area. We have a lot of orange juice industry in Brazil. And also use some tools inside DWC that I really love is the use of artificial neural networks to work with some unusual examples, like simulate the mixing different colors, estimate the global heat transfer coefficient in a heat exchanger using artificial neural network, also estimate browning in a pasteurization process with Maillard reaction. So it's very, very good tools to do that. So is also Nemir sent to us a question. Yes, it's possible to work with crystallization and evaporation. It's possible to do that. We work a little bit with this here in also with GEA process here in Brazil. GEA is a huge industry from Germany. So as Anna introduced the presentation, also I worked together with Daniel Wagner to create the voice commander extension for the WSIM. And in this extension makes the WSIM more accessible to user with special needs. And now it's possible to use your voice to create, edit, save flow sheets, as well to add, edit, remove, connect flow sheet objects, and also create and view results reports. And it's also this extension provides the spoken feedback for the voice comments, so it's very, very good. Now we are working to expand this. We could work now with English and Portuguese, and we thinking about to expand for more language if more users start to work with this voice commander. So also with Daniel Wagner, we through this extension we decide then yes, it's free to use it with special needs, and if someone help us with the WSIM social responsibility program, that is the case that I'm talking about now. We have the WSIM social responsibility program. We send the license free of charge for the someone that help us with this project. And through this social program, we collect donation worldwide, and now we donate food for about 30 families in case of extreme poverty here in Brazil. So if someone are interested in donating for this cause, please enter in the WSIM webpage, and you could learn a little bit more the ways to contribute with this beautiful social project that we made here in Brazil. So thank you very much for all guys that could help us in this project. So another project that we made here in PUC Campinas, we have another very good teacher, the Professor Priscila Firmino. She with her students creating a walking stick that use Arduino tools to warm the visual impaired to the presence of wet ground. It's very, very good. So this is help us a lot here. So Daniel also sent to us in the chat that we make this extension for the special need people with special needs, and also send this extension free of charge for the supporters of the WC Patreon program and also my YouTube channel. So also all of money that I receive from YouTube, I send to this project and donate all of this money to the WC responsibility program. So the last but not least project that I would like to share with you is this case. It's what I call the Industry 4.0 lab project. And in this project, we use DWSIM, ESP32, Blink, IoT, and Google Sheets. So it's a very good idea. We have real data collected in a reactor or in a heat exchanger here. Collect this data using ESP32, send this data to the IoT Blink. It's also a free tool that we could use and share IoT data with user and the students, and send this data to the Google Sheets cloud, read this data in real time with inside the DWSIM. So using Python script, we read this data from the Google Cloud and perform optimization with artificial neural network in real time, and then go back this data from the WC to the cloud, and this cloud go this data to ESP32 and use this data to have a better control of the reactor. So it's a project that we use industrial Internet of Things with Blink IoT. We send this data to the WC through the cloud using Google APIs, and make a real-time optimization with DWC and Python. And also, yes, it's possible to make pinch analysis for the hot and cold stream analysis with the WC. Yes, it's possible to do that. So this is very good. So here we can take a look. This is the real data, and then this is a heat exchanger, the Arduino, the ESP32 data here, and some analysis that we could use here. So, yes, I make this project here in my house, but we use this project with and for the students. So it's a very good idea to help the teaching of DWC and artificial neural network here in Brazil. So the conclusion is, so why open source? So open source help us to encourage innovation through the collaboration, lower the total cost of ownership. Is very good to make remote classes also. We force multiplier, we attract students, we have the obligation to give back to the community. we also learn how to code, and is fun. This is the for me it's really fun to work with DWSim and other open source tools. So this is the idea. So excuse me again my poor English. So that's a long time that I do not speak English. I hope that you could understand me a little bit. So this is the idea that I would like to share with you guys today. And you have all my contacts here. You could contact me with my email, with my WhatsApp, also in this Linktree link that I share with you. I will share it with you again here in the chat. So you could click and have all my contacts, my Instagram, my LinkedIn, my WhatsApp, and email also. You could contact me if you have some questions. And now we are open to cast questions that you have. Thank you very much for your time.
Thank you very much, Nicolas, for this